Hello and welcome to our discussion of accuracy and precision. With our density lab, we will be doing some measurements, and how we take those measurements is going to be able to affect how well we can be accurate in our description of our answer and how precise our measurements are going to be. So sometimes these words are used interchangeably, but they actually do mean separate things. So here, for our learning objective, you should be able to distinguish between them by using an example and calculate percent error values to describe accuracy of experimental data. We're going to focus right now just on the definitions and comparison of the two. So accuracy is when a measurement that is taken is close to the accepted or true value. Think of that as getting the right answer. When you're accurate, you did it right. Precision more describes when you get consistent results under the same conditions. So if someone was doing a repeated lab experiment and they were taking a certain mass of a sample and they consistently got the similar results in that procedure, that would be precise measurements. You don't have to be high in both of these at the same time because they are not the same measurement. So let's imagine that you were an archer and you shot a bow at the target, or used a bow to shoot an arrow. Let's be careful here. And you shot a bullseye on your first try. And then you were a little bit off, but you're still in this nice black region. And then your last shot was over here. They're not super close, but they are close to the bullseye. That means that these ones are accurate. They are close to the expected value. Now let's say that you hit on another target something like this, where those arrows are practically right on top of each other, but they're a pretty clear distance away from your target, where you wanted to hit. This example would have precision. You had repeated consistency under the same conditions, you hit the same spot, but you weren't correct. You didn't hit what you were aiming for. Now, to be both precise and accurate, that would be a great shot, hitting that center of the bullseye almost exactly each time. So in this situation, you would be both accurate and precise. Now there's a spot on your note sheet to be able to draw in your own X's representing those hits, so make sure that under the labels you put in the correct representation of those results. Now when we think of that in a scientific experiment, we want to be as precise as possible when we do our measurements. In order to show correctly what precision they have, we are limited by how many digits we state in our answer. For example, if you measure something with a ruler to 5 centimeters, you could, if it was exactly 5, say it was 5.00000000 centimeters. But depending on the tool you use, you probably don't actually know that it's exactly 5 to that level of specificity. You might only know 1 or 2 decimal places. Scientists know that the tools they use are going to limit the precision of their measurements. So, take a look at these two rulers. Notice that the hash marks are different. So if we wanted to make a measurement with this ruler, what the eye can determine is tenths between the hash marks. So if we look here, I'd say this one is 4.123 and something. We'll say 4.38 for our centimeters. I was able to know it's at least 3, but it's less than 4, and it's pretty far to the end. Now with this ruler, the only one I actually know for sure is the 4. I have to estimate the next digit. So this one we would say maybe 4.3 or 4.4. So notice that these two measurements, one is more precise. This one was able to give more specific data because of the type of ruler that we used. This one was not as precise, and we are limited by the fact that I only know for sure that it's between 4 and 5, and I have to estimate that final digit. So here, for this question, what do we call that final digit? It is the estimated one. So whenever you take a measurement, you need to give me every possible digit you can with respect to the tool that you're using. Always estimate one digit more than what the hash marks or the graduations on your tool allow you to use. So if we look at these here, these hash marks on this old school stopwatch are for every 1 second, whereas this digital readout gives us to the hundredths of a second. So this one here, that 0 is actually the estimated digit because it's reading out digitally. That would make this one the more precise measurement. This one can read to the hundredths. This one would only be able to read to the tenths with that estimated digit. Our goal in science is to always give the most precise measurement possible, but we're always limited by the tool that we're using when we make those measurements.